Jing Chen, and I'm a member of the local committee. And I'd like to spend several minutes before this formal session of the conference to introduce some important things related to the Peking University campus and the conference. First, about how to access the Wi-Fi internet in this room. You can find the name of the Wi-Fi is AGI dash wireless, and the password is AGI 2016 PKU. And we have posted at the back door, and if you can't remember it, you can check it on that paper. The other thing is how to get a place to have food at your lunch or dinner. You have a map in your bag, and you can find several places to get food. First, now we are in the building 1 of Zhongguanyuan Global Village. There are 2 restaurants in this village. They are labeled on the map as 9 and 10. In these 2 restaurants, they provide English menu, so don't worry about how to communicate with the assistants there. And everyone should have a badge, and there is a blue label on the badge. It's important. Please keep it on, because when you enter the campus of Peking University, you need to show this to the guard of the gate. There are several gates. You can enter the campus by showing this one to the guard. And there are several places for getting food. First, on the map, please find the label 6.
The map wasn't.
Really?
The map wasn't in the back.
I was the only one, or?
Oh, yours was?
Yeah, I believe.
In the back?
Sorry for that. Please find the label 6. There is a big dining hall. You can't pay cash in the 3rd floor and the 2nd floor, but you can buy food with cash on the 3rd floor. The other one is label 5. There is a coffee shop there, and it's very popular for overseas students in Peking University. And then the area between the label 3 and 4, there is a Subway, the chain store there, so you can get a sandwich or some other fast food there. And there is also a supermarket there, and you can buy drink and snacks there with cash. And for people living in Xihua Hotel, it's easy to get food there because there is a food street near the Xihua Hotel, KFC or Pizza Hut. You can get many restaurants there, so don't worry about that. And we also have volunteers in this room, at least 2 students every day. And their names and contact information are also posted in that area. So if you have any problem or meet trouble, please feel free to let them know. They will help you. And we also have break time between 10 to 10:30 in the morning and 3 to 3:30 in the afternoon. You can get coffee and tea just outside the door in the corridor. Thank you very much.
Hi and welcome everybody. My name is Ahmed Abdel Fattah, one of the two organizers for this formal magic workshop. I'm glad that you are here. I will just give a quick walk through the schedule of this event. First of all, we will have 2 sessions. First of all, I have to thank the people who couldn't attend, the people who helped in organizing this event, the reviewers and everyone else. Some of them are already in this room, so thanks a lot, and thanks for those who couldn't attend. So first of all, we have first 2 sessions for this workshop. The first session talks about cognition engineering, and there will be an invited talk by Professor Shi, followed by 3 talks by the author of 3 accepted papers. Each talk is 10 minutes and maximum 5 minutes for question and answering. But we have scheduled the starting time just to cover any lag in preparation and this stuff. So we will have the talk immediately after my quick walkthrough. And then we have 3 presentations. Then we will have general discussion for the first session. Unfortunately, we don't have time to get break, so we will start immediately after that with the second session. Okay? Formalization and modeling, and also it has a similar structure. So we will first start with the invited talk by Professor Shapiro, and then 3 talks of the accepted papers for the workshop, and then finally we have the last general discussion. From 12 to 2, according to the schedule, we know that we have the lunch break, so just I will let Professor Shi come to the stage and present the first invited talk. So let me first introduce Professor Shi. He is a professor at the Institute of Computing Technology, Chinese Academy of Science, leading the Intelligent Science Laboratory. His research interests include intelligent science, cognitive science, machine learning, multi-agent systems, semantic web and service computing. Professor Shi has published as many as 14 monographs, 15 books, and more than 450 research papers in journals and conferences. And he has won a 2nd grade national award at Science and Technology Progress of China in 2002, and 2 2nd grade awards at Science and Technology Progress of the Chinese Academy of Science in 1998 and 2001, respectively. He is a fellow of CCF and CAAI, senior member of IEEE, member of AAAI and SEM, chair for the WG 12.2 of IFIP. He serves as editor-in-chief of series on intelligent science. Please welcome Professor Shi.
Okay, thank you, Dr. Hatta. Okay, good morning, ladies and gentlemen. They're very lucky to attend this conference. And today I would like to talk about the computational model of memory in CAM. This research supported by the China National Basic Research Priorities Program 973, and also supported by National Nature Science Foundation of China, China High Tech Program 863, and also has support by the 12.5 National Support Program. So last year, the AI magazine appeared I think it's a very nice paper, written by the Dr. Adam and Professor Bach and Dr. Ben Gotta and other persons. They are summarized several years the AGI, the activity. I think this paper is mapping the landscape of human level artificial intelligence. So the point out the goal of artificial general intelligence is the development demonstrate of the system that exhibit the broad range of general intelligence found in human. I think it is very, very nice. The point out the AGI. What is good, and also I like this very much. This picture is show the Predicate, the very famous cognitive scientist, and another come from the Russian is because it's also very famous the cognitive scientist. So this. Draw this picture show how to arrive to the full human level intelligence. From the children, development, and from the society. How to reach the human level artificial intelligence. So and also the pioneer AI pioneer, the Professor McCarthy. Is 205. I point out this is artificial intelligence. The final, the goal is reach the human level. And also he point out in order to reach this goal should use logic AI. Because Professor McCarthy is a logician person, the science professor, so he likes the logic very much. But I only cite his word here, not but his point. I think it is for us is very important for the logician, for logic, for formalizations. I only talk about this. So it is, and also he has a very detailed paper. Appear the top level of the journal is AI. Is 207, is explain why he point out this logic is important things. Also. And for the logic, I think it is very, very popular. The first order predicate logic. So everybody may be familiar with this syntaxes. I'm not going to detail. I only show it is a basic. And also the bonus 3 is very interesting. The logic is also for the semantic web. The May of the 201st, the famous paper written by Berners-Lee is a semantic web. He point out the logic is very important occupies very level is very, very important. And here, this picture comes from the 2.6. This is come from scientific science. Yeah, from the scientific web, became semantic science. So it is, web science. Yeah. So he put this logic framework is here. Point out how the important is unified logic. How to get the unified, the logic, to support the semantic web. So I think it also, show us the logic is a formalization, very important things. For the semantic web, already has a descriptive logic there. Yeah, a lot of the research make a contribution and the progress there. Yeah. So in terms of the descriptive logic, this is a basic descriptive logic, the syntax in the semantic there. Yeah, there. And in terms of the basic descriptive logic, we are expanded the functions. We add the action into this basic syntax. Yeah, so we are add this action. Yeah, you add this action into the basic descriptive logic. So we call this is a dynamic descriptive logic because we have put the action into the basic syntax there. The action, concentration, we are used like the product system. Yeah, as you know, so far most of famous the cognitive system is use the product system, such as the STR and also SOL like this. So use the product system. In the dynamic descriptive logic, we also extend the action. Yeah, looks like the format, the similar the production system. So I think it is very simple, but very powerful, very powerful. So we are use the simple and the powerful such syntax for the dynamic descriptive logic. Yeah. So this is a dynamic the descriptive logic, the definition. Yeah, here I'm not going to detail. So here I only focus on this. The action, the parameter, then is a precondition, and the result, effection. Yeah, precondition and effection, like this. So we are called this as action, structure. So here the each symbolic, the meaning is here. So this is a semantic. It's also we are give the definition here for the DDR, the semantic. So I think the DDR is a powerful. Here I only make the two example. Use the DDR we can implementation. Otherwise we can very difficult to cannot implement here. So for the action theory and also for the domain theory, so we can use the DDR is very easy to implementation. And listening to maybe almost 10 years, we are proposed the new cognitive mind modeling. The new mind modeling. We call this CAM. The CAM. This is a consciousness and the memory, because this is the mind modeling. The emphasis, the consciousness and the memory, the rule and the functions. So we call this new mind modeling is a CAM. So consciousness and the memory. So here I show the CAM, the architecture here. So this here is a basic is a consciousness, and this is a memory, and high level the coding function. This is I/O, looks like I/O. So this can constitute the CAM architecture. So this CAM architecture consists of the 10 modules or components. Yeah, this contain the visual model, the oral model, the sensory buffer, and the working memory, short-term memory, long-term memory, action selection, response output, constitute consciousness, and high-level cognitive function. Yeah, so consists of the 10 components here. So this talk we are focused on the memory, only focused on. So memory, the hierarchy, you can see this is a memory hierarchy. So for the memory, we can set up to separate into the mainly three the memories. One is the sensory memory, and the short-term memory, and the long-term memory. Yeah, long-term memory. And the short-term memory, we can separate the short-term memory and the working memory. Yeah, working memory. And for the long-term memory, maybe consists of three kind of memory. One is a semantic memory, and also has episodic memory and the procedural memory. So here, this is a memory hierarchy consists of in the CAM system. So for this is a long-term memory. So long-term memory consists of semantic memory and the episodic memory, procedural memory. Yeah, can separate into the three kind of memory. For semantic memory, everybody maybe knows this. Yeah, so concept. Yeah, this is semantic memory. Yeah, keep the concept. Yeah, the memory is this. So here we can we can use also we call this semantic memory is a declarative memory. So it is contains the general knowledge and also concept. So for example, the word knowledge or vocabulary, law, knowing awareness like this. So this is the traditional and very classical the example, because everybody know for the very early the export system also has some law, how to construct the law. Also use this picture. So animal, yeah, if they go to the zoo, you can use this law, can judge what kind of animal, yeah. So here is also the animal. We can contain the bird and the fish like this. This is semantic memory. So in this memory, so we can use the dynamic disk logic very easy. Yeah. So this is only use this. Looks like the first order logic is use use this. This can represent the semantic memory, or use like the use or. Yeah, you can this. Yeah. Yeah, here in our CAM system, we have the episodic memory. This episodic memory, we use two levels. The low level, we use a senior. Yeah, senior. Yeah, this is senior presentation. This lower level. The top level, we use logic. Maybe everybody knows this. Now, a lot of paper related to the image or video processing. For the image video processing, we are mainly do some feature extraction, then get some the clustering or classification or label this image or video. So we are here. So in the CAM system, we use these two levels. Yeah, so low level, yeah, close to the feature, the original, the nature, the image or video. But after, yeah, processing or extraction or data mining like this, then you can get to the top level. We can use the DDR to represent or describe this, the image or video. So this is the CAM. I think is a good feature here. So we are use two level to describe the episodic memory, not only the one level, the low level. Yeah. So it is. I think it is a good feature here. So the episodic memory, the described here. So this is a low level, the scene, and here we have some level, the described this episodic memory, because the episodic memory for the cognitive science is a very important things. I remember the 1988. I attended this fifth generation conference. Yeah, the Professor Simon, yeah, point out if we can go process the image, then maybe we can get the activations is jumps a big step. So it is very important. So here we are only one. So we are use the low level and the top level. Yeah. So can not only the low level. Yeah. The stop the low level. So we are also has a top level can use the DDR to describe this structure. And for procedural memory, so just I already talked in the HDR and SOAR use the product system. So in our the CAM system, we also use the action like this. Looks like it's a product system. We call this action. This statement to describe the procedural memory. Procedural memory. So the action format, we can use this. Yeah, looks like this, and this very close to the production system. The if then, yeah, this law. Everybody knows this. If then, yeah, it is very good. I think it's very simple, but very powerful. They can place the knowledge and the procedure. So, and also we can use the XML to describe, to use the DDR that describes the procedural memory, here. This example is say the lock the door, you have to describe this, the situation, lock the door and open the door like this. So we also can use the XML describe here. So just I talk about the long-term memory. So for the short-term memory, short-term memory here. So this short-term memory, so we are use the look like the agent, because originally I do a lot of work on the multi-agent. So we are familiar with the agent. The agent is a famous. The model is a BDI. Brief, design, and intention. This is very famous. So for the short-term memory, we also use the BDI. This BDI, this model to describe the short-term memory. So you see the brief, the desire, and the goal. Intention, then planning. So this is also very useful for the describe the CAM, the short-term memory. So I think it is a lot of research efforts and the paper related to this. So we also can use this. So for short-term memory, we have the brief knowledge. Use the three chapter. Yeah, this structure to describe short-term memory, and we also develop some algorithm for the brief revision, and the goal the algorithm. Yeah, this goal. And also, we are developing some action planning. Yeah, use this to do this. Develop some algorithm for action planning. So this for short-term memory, and for working memory. Working memory is, I think, this updated structure for the working memory. But I think it is important is this. Yeah, this is central execution. So central execution is more important. Is influence engine. Yeah, looks like the influence engine. So in this system, we are use the extended tableau algorithm. Yeah, this is because for the distributed logic is use the basic tableau algorithm. This check the consistent, check the consistent. So in our system, we only add some consistent check. Some looks like this such as the action, this active box. Yeah, this check this the consistent there. So we are So because the tableau influence engine. Yeah, so we are use this. So in our talk, I think this one is our Dr. Haron. Yeah, is proposed this workshop. I think it is important because formalization of the code mechanism and the human ability is very important for the AGI. And also this paper, this talk, I show the computation model of memory in the CAM and use the DDL to formalize, to describe the memory, the computational model. Okay, thank you for your attention.